With this equation, we will need to get rid of the radical by squaring both sides, but first we need to isolate the radical. So move the 2 to the other side, to the right-hand side, by subtracting 2 from both sides. And then you can square both sides. On the left-hand side, the square and the square root will cancel each other out, leaving just x minus 8. On the right-hand side, squaring a negative 2 makes a positive 4. And then add 8 to both sides, so we would have 4 add 8 is 12. But whenever you square both sides, it is possible that even though you did the algebra correct, that this is not correct. So you have to check the answer. It's just when you square both sides that you have to check the answer. So with this one, go back and substitute in a 12. So 12 minus 8 plus 2 equals 0. This is really a question. Did it work? Well, this is going to be a 4. So take the square root of 4 is 2. So is 2 plus 2 equal to 0? No. So you throw that answer away. There's no solution. The reason that there's no solution is the square root function, because of x minus 8, the square root function has been shifted, and because it's minus, it actually shifts it to the right by 8. So it goes to the right by 8. So you go to the right by 8. And then, because of the plus 2, it's been shifted up by 2. And then have the square root function. And then this problem is saying, when is it equal to 0? Or in other words, when does it hit the x-axis? It doesn't. To solve this one, well, when you take absolute value, it takes away negatives. That means there's the positive case and the negative case. Look at a simpler example. The absolute value of negative 7 is equal to 7. The absolute value of 7 is equal to 7. So you have to take into consideration the positive and the negative case. So what we can do is say x minus 5, and then you have the positive case on one side and the negative case on the other. You could do this as two separate inequalities. Say there's the one with the positive case, there's the one with the negative case, or you could just do it all at once. So then we would need to add 5 everywhere in order to isolate x. So it would be 4, and then x in the middle, and this would be a 6. So it's good to have the algebra skills to do this, but also by the time you're in pre-calculus, you should be able to visualize graphs as well. So the absolute value graph is a V. And then this x minus 5 actually shifts it to the right by 5. So it's a V. Okay, that's the left side. Then it's saying, when is that graph under 1? So here's 1, and if you go across at a height of 1, it says, when is it under that? Well, it's under that from here to right there. That's when the V is under the red line. And then this is saying that's going to work when x is between 4 and 6, which to me makes perfect sense. Go to the right by 1, go to the left by 1, it's between 4 and 6.